So, what I have been giving you so far are things like this. F of x equals 3x to the third minus 7x plus 2, and saying something like find the zeros. Right? That's what we've kind of been talking about so far. What we're going to be looking at today is going to be 3x to the third minus 7x plus 2 equals 0. Find solutions. Or sometimes they'll be called roots instead of solutions. The way that you do this is going to be very similar to what we've already been doing. It's just a little bit different as far as the setup goes. Yes? Oh, sorry about that. Oh, come on, Caden. All right. So they're very similar. There are going to be 4 different ways that we are going to solve these here. So one of the key things that you need to remember, this is the same thing from that fundamental theorem of algebra, you will have the same number of solutions as the degree. So it's just like our zeros. We have the same number of zeros as our degree. We also, if we have an equation, we have the same number of solutions as the degree. So if you have x to the 4th power as your highest exponent, you're going to have 4 solutions for that. So we are going to try to graph as much as we can. If we can graph it, we're going to graph it. Right? It's a very effective way of solving this that is pretty easy for us to do. So we're going to work on graphing. If we can't graph, we might have to factor. Most of the time, you can do the ones that you can factor by graphing. So we're not going to have to factor very much, but it might show up. If factoring doesn't work, we might have to use quadratic formula or complete the square if you remember how to do that for Math 2. I'm not sure Ms. Swisher even did it with regular Math 2 last time because it's kind of tough. But if you remember how, go ahead. It's fine. Most, I think, would use quadratic formula there. These are going to become more and more rare. You're not going to have to do this too often, right? And then the last is going to be for higher degree polynomials when we've got something like 4th, 5th, 6th power. We might have to graph and then use, it says synthetic division. We did not do synthetic division. We did long division. These are Miss Martin's notes, and I didn't change that because this was a picture and not a text where I could change it. They do synthetic division in 3 on top of long division. We do not do synthetic division in here. So technically, synthetic division is not in the curriculum. You don't have to do it. It's just a different way that they look at over there. So this is like the hardest one, and we're going to run into a few, but you're not going to see a ton. Like this is, you got to know this to be able to get 100 on the test. You can probably get 90 if you don't know how. All right. By graphing. First big thing we got to remember, the only type of solutions that will show up on your graph are real solutions. Any imaginary solutions will not be visible. So if you graph your function and it looks something like this, you would have your x-intercepts would equal your real solutions. But you could have imaginary solutions. So it's going to depend on the problem to know whether or not you have those. So if they're all real solutions, it's going to be really easy to find them by graphing. And that's what we're going to look at first. If you have imaginaries, that's when it gets a little bit more complicated. Good news is sometimes they don't ask us what the imaginary solutions are. They just ask us if there are any. And we can kind of tell that without having to solve it out all the way too. So let's look at what we've got. I have already taught you how to solve any equation on Desmos. Where's my Desmos? I guess I closed it. All right, I've already taught you how to solve any equation. What we have done before is we have done f of x equals 3x to the third minus 12x to the second. We did f of x equals the left side. We did g of x equals the right side. And then we could find our solutions. That still works. Okay, so that is still a valid way to solve this this function or this equation. But, and you can still do it. It's fine. I don't mind. However, there is going to be something that comes up with those double roots, like that we're not going to be able to see unless we move everything to one side first. So on these problems, I would suggest moving everything to one side, because if we do that, we'll be able to tell if things are double roots. If we do it the old way, we won't be able to tell if we've got double roots for that. So, our steps for solving by graphing. I've went into great detail here because there's a lot of things I want you to talk about. It's actually very easy, but there's several things I want you to think about. First thing I want you to do on these is move all the terms to one side so that the equation is equal to 0. So we want everything on one side. So in this case, I would take the 6 and the negative 15 and move it to the left side. You could move the other ones to the other side. It doesn't matter. But when you move something to the other side, what has to happen to it? It's going to change its sign, right? So that positive 6 is going to become a negative 6. And that negative 15x is going to be a positive 15x. That's going to be equal to 0. So you want to move everything to one side first. Then, this is not so much something you do, but just something you want to think about. Number 2 says, look at the degree of the equation and determine the number of solutions. So I'm looking for my highest exponent. Right here it is 3. So I'm making a mental note that I should have 3 solutions. There. All right, so I need 3 solutions. Then I'm going to graph the expression y equals whatever I've got here. Don't put the equals 0 on the end. It won't do it right. So I'm going to go over here and I'm going to graph y equals 3x to the third minus 12x to the second minus 6 plus 15x. And that is going to graph this for me. I think I typed something in wrong earlier when I typed that in the other way, because I was getting different answers. Also, that should be a y. You could also call this f of x if you would prefer. Right there, it's fine. Y, f of x, doesn't matter. All right, so when we get this graphed, we are going to look at the x-intercepts. That is because that is where our y is going to be equal to 0. Right? So our x-intercepts here is where y equals 0. If you think about doing this equation like we were doing the others, I could put like my g of x equals 0 here if I wanted to see where they cross. It's just the same though, because it's just going to be those x-intercepts. So in this case, I'm getting x equals 2 and x equals 1. But how many solutions was I supposed to have? Supposed to have 3. And I only have 2. Why do I only have 2? Right here, what have I got, Hector? I got a double because that's just a bounce, right? So that x equals 1, it's a double root or a double solution. So it counts twice, so I found all 3 of them that I need. So this doesn't have imaginaries. It's got 3 roots, even though it's only 2 distinct roots right there. I typed something in wrong on that first one, the first way I did it. Let me just... Yeah, this is what it should have looked like on the first way that I did this. I also like moving everything to one side because it's just a lot easier to see. Like these cross right here, I think, at 2. They should cross at 1 if I zoom in a little bit. There they cross at 1. It's really hard to see that they're crossing right there. So it's easier to see as well if you move everything to one side first. Okay? This is what we're going to do most of the time. Right? This works most of the time here. But sometimes it might not. Or we might run into some problems. So I'm going to skip 2 because we need to be moving through this pretty quickly. We need to review a little bit today too. So let's look at example 3. Now before I can do anything for example 3, what's the first thing I need to do to that equation? What do we do, Hector? What? Move all those terms. So we're going to have x to the 5th plus 4x to the 3rd plus 16x squared minus 4x to the 4th equals 0. And so if I want to do this in Desmos, I'm going to go over here and I'm going to do y equals x to the 5th plus 4x to the 3rd plus 16x to the 2nd minus 4x squared, to the 4th. And if I look here, I'm getting negative 1.391. So x equals negative 1.391. And I'm also getting 0. Now, are either one of those double? One of them is. Which one, Carson? Which one's double there? That second one, that one right there at 0, right? So this is a double. Now, how many solutions do I have there? It's 3, right? How many am I supposed to have? 5. And when you see this happening, you might need to like zoom out because maybe it just like turns back down, but I'm zooming pretty far out and I'm not seeing anything like that happen, right? So I don't think that's the case. So this problem, I can find my real zeros, but what's happening here is that I might have 2 imaginary. Maybe. Or it could be something like my double root's really a 4th root. It counts 4 times or something like that. Or this root right here might count 3 times. I really can't know without looking at it a different way. Right? So I put this problem here to kind of lead us into there's going to be some times where just graphing won't work. Just graphing will get you your real zeros every time. So you should be able to see the real zeros on the graph every time. But imaginary, you're not going to be able to find from the graph. So, questions so far? All right. So, if we are going to factor, okay, we have already learned how to factor. We just didn't do it for solving. So, if we are going to factor, anytime we factor, we need to pull out a GCF, right? So, in this particular case, what could I divide all those terms by? 4, and I could take out a x. So, I've got 4x is going to come out. So, I got 4x, and then that'll leave me x squared plus x minus 6. And then I want to factor the stuff on the inside with that x method if I can. So I need to multiply to get negative 6. I need to add to get a positive 1. What numbers could I multiply to get negative 6 but add to get positive 1? Got it, Samara? Negative 2, positive 3. That'll work, right? Negative 2 times 3 gives us negative 6. Negative 2 plus 3 gives us positive 1. So I will get x minus 2, x plus 3. So in this case, my zeros, right, are just the opposite sign. So like I'll get x equals 2 right here. I'll get x equals negative 3 right here. What about that 4x? What do I get when I have that 4x? Just a 0 right there. How many solutions was this supposed to have? 3, because that's my highest exponent. I've got 3 right here. This looks good. Now, that one would have graphed. I could have graphed it, right, because I got whole numbers. But sometimes it will not. There. So we're skipping through. I think this one graphs also. I'm pretty sure. So here. Let's graph on this one instead. So if I graph this one, I would need to move that 27x squared to the other side. So 9x to the third plus 3x to the fourth minus 27x squared would equal 0. So if I graph that, y equals 9x to the third plus 3x to the fourth minus 27x to the second. I've got 3 different ones here. So I've got x equals negative 4.854. I'm getting x equals 0, and I'm getting x equals, what is this one? 1.854. Now that's only 3 solutions. How many am I supposed to have? I'm supposed to have 4. So let me look at my graph. Fernando, what have I got at 0? Multiplicity of 2. So this one is double. It counts twice. Right here. So even though it only looks like 3, it is actually my 4 solutions that I need for that. Now, what you might see is they might have used quadratic formula to solve this. So instead of getting negative 4.854, it might give you something crazy like 2 plus or minus the square root of 7 or something like that. Just type it in the calculator, see if it matches your decimal, right? We can get around having to do that quadratic formula that way. Now, something like this is going to be the most difficult. Clearly, like it looks bad, right? So let's do one of these, because this is the I'm going to make 100 on the test problem, right? Here. And what you would have to do in this case, the first thing you really want to do, no matter what, move everything to one side. I'm going to suggest, even though you got to move more things, moving everything over here. That way your x to the fourth is still positive, because it makes it a little bit easier to deal with. So you're going to change the sign of everything when you move it over. So I've got x to the fourth minus 5x to the third minus 10x squared minus 20x minus 56. And I am going to graph it, because I can find real zeros. This way. Okay, so we are graphing this, and it is looking like I just have 2. Looks like I've got negative 2 and positive 7. Right? Negative 2 and positive 7. So here is what's going to happen with these. I've got x equals negative 2. I've got x equals positive 7. For that, we should have another one. No, it's okay. Actually, no. How many zeros am I supposed to have for this? 4. So I've got 2 real. What's that tell you about the other 2? Probably imaginary, right? So here is what we're going to have to do. We're going to have to do some long division on this. So it doesn't matter which one of these you pick first. You need to come up with the factor that goes with it. So x equals -2 would be the factor x plus 2, right? Our factor, we change signs. And we're going to have to do some long division here with x plus 2. So x to the 4th minus 5x to the 3rd minus 10x squared minus 20x minus 56. Okay, so I'm going to have to ask myself, what times x gives me x to the 4th? That is x to the 3rd. And then I multiply that back. X to the 3rd times x is x to the 4th. X to the 3rd times 2 is plus 2x to the 3rd. And then I will need to subtract, which cancels this one and gives me -7x to the 3rd. And I'll bring down my 10x squared. And so that'll be my first step. Then I ask myself, what times x gives me -7x to the 3rd? That's going to be -7x squared. And now I need to multiply. -7x squared times x gives me -7x to the 3rd. -7x squared times +2 gives me -14x squared. Okay, I will subtract here, which means really I'm adding that 14, so I get 4x squared. I'm going to bring down my -20x. Okay, I've got to ask myself, what times x gives me 4x squared? That is going to be a positive 4x. Notice all you're doing is taking the x away from whatever that term is. So 4x times x gives me 4x squared. 4x times 2 gives me a positive 8x. I need to subtract. So that's going to give me -28x. And then I need to bring down that -56. And I have to ask myself, what times x gives me -28x? That's a -28. -28 times x is -28x. -28 times 2 is -56. Both of those terms are going to cancel out. I'm out of room to write that down, but they do both cancel out whenever you multiply. So here is what you've got. So what you've done is you have factored this. So now you've got x plus 2 times x to the 3rd plus x to the 3rd minus 7x squared plus 4x minus 28. Like you factored that out. Okay, you're going to have to do long division again with your 7. Okay, don't start from the beginning. Use this new term. So use x to the 3rd minus 7x squared plus 4x minus 28. And we're going to, here that's a positive 7, so we're going to use x minus 7 as our factor there. So we've got a long division this again. What times x gives me x to the 3rd? That's going to be x squared. So x squared times -7 7x squared. Now watch what happens here. Both of those end up canceling. So then I would just have nothing. I would bring down my 4x because I skipped that. Was probably going to need to bring down that -28 as well. So I got to say, what times x would give me 4x? What times x gives you 4x? Just a 4. So we add 4. 4 times x gives you 4x. 4 times -7 gives you -28. Both of those cancel. So you get x squared plus 4. So what that means is my problem now is x plus 2 times x minus 7 times x squared plus 4 equals 0. So that division has factored this out. So when I'm finding the zeros here, this one just gives you x equals -2. This one gives you x equals 7. We already knew those because we found those from the graph. Right here, you've got to do x squared plus 4 equals 0. So you will move that 4 over to the other side. That'll be x squared equals -4. Then how do you undo a square? Square root. So I square root both sides. So x equals plus or minus 2i. So my solutions are -2, +7, +2i, and -2i. Those are my solutions that I get here. I'm supposed to have 4. I do have 4. Most of them are not this difficult because most of them don't actually ask you to find those imaginary zeros. Most of them will just ask you to find how many imaginary zeros there are. But this is what you've got to do if you run into those problems, right? Are you going to see a lot of this? No. 1 or 2 maybe on the test. To make 100 on the test, you need to know how to do this. To make a 90, you could probably not know how to do this and be okay. All right. So don't get too laser focused in on that if long division still scares you. All right. So we are not going to do